The square root of 144 was the first problem in your homework for 3.5. The value under our radical isn't negative, so there won't be an I in the answer. Our second step is to look for any perfect squares. It may not be obvious to you yet, but you'll get very good at picking out perfect squares. And in this case, the square root of 144 is 12, and now that we're in Algebra 2, it's plus or minus 12. Problem number 7 on your homework for 3.5 was the square root of negative 25. This time, the value under our radical is negative. So I'm going to start factoring, and I'm going to start by separating the negative 1 from the 25. And then I can use our AB property to make that the square root of negative 1 times the square root of 25. We already know 25 to be a perfect square as it is, so I'm not going to factor any further. So our answer to this is going to be I times the square root of 25, which is plus or minus 5. But by convention, to tidy this up, we do put the number in front of the I value. And our final answer is plus or minus 5 times I. Problem number 9 on your homework was 2 times the square root of negative 16. I'm going to leave the 2 out front as we work with what's underneath the radical. Because the value under our radical is negative, I'm going to start by factoring out a negative 1. So it's negative 1 times 16. Now I'm going to use the AB property to separate out that negative 1 from the 16. So I'm left with 2 times the square root of negative 1 times the square root of 16. And as you can see, 16 is already a perfect square, so I don't need to simplify that any further. What I'm left with is 2 times I times plus or minus the square root of 16, which is 4. But now I have 2 times I times plus or minus 4, so I need to simplify that by multiplying it out. And I'm left with plus or minus 8I. The second half of assignment 3.5 was a little bit different. Suddenly, you have an equal sign that you have to deal with. But don't overthink it. You've done these before. I'm going to solve this just like I did in Algebra 1 by adding 10 to both sides. Now I'm left with x squared equals 75. Now that I only have an x squared on this side of my equation, I can take the square root of both sides to solve for x. The square root of x squared just equals x, but now I have to figure out what to do with 75, because 75 does not have a nice tidy square root. So what I'm going to do is go back to the perfect squares that I listed before: 4, 9, 16, 25, 36, and there it is. I can factor a 25 out of 75. I'm going to rewrite my radical, but instead of writing 75, I'm going to rewrite it as 25 times 3. Same thing, right? And now I'm going to use our AB property, separate it into the square root of 25 times the square root of 3. The square root of 25 is just plus or minus 5, and I leave the square root of 3 just as it is. And that's our final answer. This is problem number 12 on your homework, and it kind of kicked your butts. On the left side here, you have x minus 4, but it's in parentheses and it's squared. What a lot of you wanted to do when you saw this x minus 4 in parentheses squared is that you wanted to turn it into x squared minus 16. I'm going to show you why that doesn't work. Squared means that it's multiplied by itself. So when we do x minus 4 in parentheses squared, we actually have to FOIL it out, because x minus 4 squared is shorthand for this problem. And when we FOIL this out, we get x squared minus 8x plus 16, and suddenly it's a much more complicated problem. We do not want to square this. So instead, we're going to take the square root of both sides. So the square root of something squared is just that something. So what we have is x minus 4 on one side, and then the square root of 25 on the other. But now that we're in Algebra 2, we know that the square root of 25 is plus or minus 5. But this poses a problem because we have our plus or minus 5, but we still have a minus 4 on the other side that we need to deal with. And that leaves us with two separate equations that we have to solve. One of them being x minus 4 equals positive 5, and the other x minus 4 equals negative 5. And you can see that these are two different equations and they're going to be two different answers. But this is just Algebra 1. Once we have figured out this part, we can just solve it for x. So I'm going to add 4 to both sides, and I'm left with x equals 9. And then when I go over here, I'll do the same thing, but this time I have x equals negative 1. And so just like every other problem we've had, we have two solutions again, but this time it's not plus or minus something, it's two completely different numbers.